Today we're going to learn how to write congruent triangle proofs. To write these proofs, we're going to need some basic tools. These are definitions, postulates, theorems, and properties. These are all going to serve as our reasons when we're justifying our statements. Definitions can include things as basic as the definition of a right triangle, for example. If we need to use the hypotenuse leg theorem, we would need a right triangle. So we might have to say that we have a right triangle. Postulates that we could use, we've learned a set of basic postulates for proving triangles congruent. Side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg are the postulates we'll probably be using. Theorems. Anything from the theorem that says vertical angles are congruent to corresponding parts of congruent triangles are congruent to the isosceles triangle theorem. There are all sorts of theorems that we've already learned that we could put into place here. And then the properties. We used properties with our algebraic proofs. We won't use those properties necessarily with congruent triangle proofs, but we are going to introduce you today to a special property that we will need, and that is the reflexive property. Let's look at the reflexive property of congruence. The reflexive property simply states that a given side is congruent to itself, or a given angle would be congruent to itself. They would have the same measure because they are the same thing. And you might think, well, that's kind of a silly thing to have to ever use, but it's very useful when we do congruent triangle proofs. For example, I might have two triangles, and I might know that two sides of the one triangle were congruent to two sides of the other triangle. If they shared this third side, then that side has to be congruent to itself and could form the third piece so that we could say the triangles were congruent by side, side, side. So I would justify this in my proof by saying that side AB was congruent to itself using the reflexive property. We could also have this situation occur if we had two triangles that shared the same angle. In this picture, there's a small triangle on top, and then there is the bigger triangle. And I hope you can see that this angle at the top is the same in both triangles. So we might have to say that angle C was congruent to itself. In order to write congruent triangle proofs, there are some basic steps that if you follow them and do everything that they say to do, you will often have almost all of your proof, if not all of your proof, done by the time you get through the list. Step number 1, you already know. Write down the given. But now, our given is usually attached to a diagram. So it's very important that you do step 2, which is to mark the given information on the diagram using colored pencils or highlighters is very useful here. So they might say in the given that side AE, let's put an E up there, AE is congruent to EB. You'd want to mark that in your diagram so that you could see what else you needed to make the two triangles congruent. Then, when that's taken care of, there is a series or a list of things that if you go through and ask yourself, do I have this and then do it? Do I have this and then do it? You will often have the entire proof done when you're finished with your list. First thing to look for. In the given, sometimes there will be words. For example, they might say M is the midpoint of AB. These words need to be converted to symbols. So if I see up here in my diagram that M is the midpoint of AB, that tells me AM is congruent to MB. So that's what I would do. I would write AM is congruent to MB by definition of what it means to be a midpoint. If this is a midpoint, those are congruent halves. So AM congruent to MB are the symbols that represent the words used in the given. Once I've taken care of words to symbols, I look and see, is there anything reflexive that I can report? Well, sure. There's a reflexive side. Put that in my proof. Sometimes we're looking for vertical angles because we know that vertical angles are always congruent. And lastly, we want to look and see if there are any parallel lines. This is usually in a proof that it looks like a parallelogram. And the thing we're interested in here is the fact that parallel lines lead to angle congruences, particularly the z angles or the alternate interior angles. If I have parallel lines and I see that z in the picture, then I know that I have alternate interior angles congruent, and that could help me with my proof. So once I get through that list, I should now ask myself if my triangles are congruent. Up here I could see that I have 3 sides to 3 sides, so I can use one of my postulates to declare their triangles are congruent. And then if I was actually trying to prove something else, for example, if I was actually trying to prove angle A congruent to angle B, then I could use CPCTC, which says that corresponding parts of congruent triangles are congruent, and I'd have a nice proof completely done. We're going to start with this first proof. I can see in my given that CA is congruent to RD and DC is congruent to AR. So I've written my given in there. Step number 2 says to mark that given on my diagram. So CA is congruent to RD. DC is congruent to AR. At this point, I have taken care of marking my given. I start going through my list. Do I have any words in my given that need to be written as symbols? And the answer is no. Do I have any vertical angles? I do not see the X shape, so no, I don't have any vertical angles. Do I have any parallel lines? Nope, nobody said anything about parallel lines. Is there anything reflexive? Yep, I have this line here. It's in both triangles, so it would be reflexive to itself. So I can add that to my proof. CR is congruent to itself by the reflexive property. Then I'm supposed to ask myself, could my triangles be congruent? And I can see that I have side 1 to side 1, side 2 to side 2, and side 3 to itself. So these triangles are congruent by side, side, side. And that's what I was trying to prove. So I can write my proof statement, and I am finished. So let's look at proof number 2. I have gone ahead and written the given, and that's when I notice I have words in my given, words that are going to need to be turned into symbols. But before I do that, let's go ahead and mark the given in my diagram. Right now, I'm told that H is the midpoint of OT. Now, notice that it said H was the midpoint of OT only. It did not say that H was the midpoint of PA. However, it does say in the given that PH is congruent to AH, so I'm going to mark that, which does mean that H would have to be the midpoint, but we can never assume that just because it's the midpoint of one segment, it's automatically the midpoint of the other. I have to read what my given says. This only says that H is the midpoint of OT. My given is marked, and now I need to do the words to symbols bit. What does it mean if H is the midpoint of OT? Well, it means that OH would have to be the same measure as HT, and so that's what I'm going to write for my second step. OH has to be the same measure as HT because the midpoint cuts it into 2 equal halves. Whenever I use words to symbols, whatever word is there is usually what I've used as my reason. I use the definition of a midpoint. Definition of a midpoint says that this is the middle, cutting this into 2 equal halves. So that's what I used to state that these were equal halves. Definition of a midpoint. All right, I did words to symbols, and then I start looking for the other things on my list. Is there anything reflexive? No. Are there any parallel lines? No. Are there any vertical angles? Well, sure. I can see right here I have the X shape. So that means I have this angle congruent to this angle. Now I can't say angle H is congruent to angle H because there are 4 angles at H and who knows which ones I'm talking about. So I am going to put a little number in there, 1 and 2. You can add numbers to your proof. And I'm going to say angle 1 is congruent to angle 2. And the reason is a theorem that says that all vertical angles are congruent. And again, I can abbreviate vertical angles are congruent with symbols and abbreviations so that I don't have to spend all day writing this proof. Well, I have exhausted my list. So I'm supposed to ask myself, is it possible that my triangles are congruent? So I have a side to a side, another side to another side, and an angle to an angle. So I can see I have my triangles congruent by side, angle, side. So I write my final statement. Triangle HOP is congruent to triangle HTA by side, angle, side. All right, proof 3. Proof 3 says angle MNP is congruent to angle ONP. So I have to make sure I'm marking the right angles. M to N to P is congruent to O to N to P. Mark those 2 congruent. Then I have M to P to N congruent with O to P to N. I have written my given, I have marked my given on the diagram, and now I go through my list. Words to symbols. No words, no need to worry about that step. Anything vertical, nothing forming the letter X. Any parallel lines, no parallel lines anywhere. So is there anything reflexive? Yes. NP would be reflexive to itself. And I would write reflexive property here. Didn't abbreviate, but you can abbreviate. And then I've run through my list. I should ask myself, are my triangles congruent? Well, I have an angle to an angle to an angle, and a side to itself. So I have angle, side, angle, because the side's included between the 2 angles. And therefore, my triangles are congruent, and I have proven my point. All right, this is the last proof we're going to do together. We have PQ congruent to TS. We have angle P congruent to angle S. We start going through our list. Do we have words that need to be written as symbols? Nope. Do we have anything reflexive? No. Do we have parallel lines that might lead us to angle congruences? Nope. Do we have our friend vertical angle? Yep. Right there we have our X. So I'm going to call that angle 1 and angle 2. And I can see that angle 1 would be congruent to angle 2 because vertical angles are congruent. I've exhausted my list, so now I check my postulates and see if my markings fit one of my postulates. Angle to angle, side to side, and angle to angle. Well, I have angle, angle, side, or angle, side, angle to choose from. Both of them have 2 angles and a side. The question is is the side between the angles. This side is not the side between the two angles. So I can't use angle, side, angle. I'm using angle, angle, side, not included. And now I have proven that PQR is congruent to triangle STR. Now, we haven't talked about CPCTC in this video yet, so let's suppose that we hadn't been asked to prove that the triangles were congruent. Suppose instead it said prove angle Q congruent to angle T. Well, there's absolutely no way that Q would be congruent to T unless the triangles were congruent. So I would first have to do a proof showing the two triangles congruent, which we've done. And then I know that if the triangles are congruent, by definition of what it means to be congruent, all the angles and all the corresponding sides of those triangles have to be congruent. And that's when CPCTC comes into play. I could now state that angle Q is congruent to angle T because corresponding parts of congruent triangles, and that's what we proved, we showed that these were congruent triangles, are congruent. So CPCTC is a way to extend our proofs and to do something a little more exciting than just proving the two triangles congruent. We are going to practice this in class tomorrow. I've given you 2 practice proofs right now to try on your own. Make sure that you have written down the given, marked your diagram, and then gone through that basic list and written down every one of the things that you can write down. Then ask yourself if you have enough information to choose a triangle postulate to prove your triangle is congruent. I'll bet you'll be surprised how far you can get on your own if you just think about what we've learned in the video, maybe go back and watch the proofs again if you need to, and then tomorrow we'll be prepared to practice in class.